Just a quick recap on what we discussed in yesterday's session. We started with what is data modeling and why data modeling, and the different types of data modeling or the phases of data modeling. So, what is conceptual data model and what is the logical data model, physical data model we discussed. And then I moved on to discussing the cardinality. What is cardinality and what is relationship? When it comes to Power BI, relationship is nothing but filtering. I explained to you what is filtering behind the scene. Once you create a relationship or establish a relationship between the tables, how the filtering is happening behind the scene, that is what I explained you. Followed by that, we have implemented a simple retail star schema, not star schema, the dimensional tables, and we implemented the data model. So that one was kind of a snowflake schema. Okay, yesterday what I have shown you was the snowflake schema, because the category dimension table was not directly linked with the sales fact table. Instead, the category dimension table got linked with the product dimension table. So that's how the category table can filter the sales fact table. Unlike other dimension tables, the category table, if I want to use it to filter my sales fact table, it has to filter the sales fact table via the product dimension table. Okay. That is what we discussed. And then I started explaining what is star schema. And as part of this, we have explored. So what do you mean by dimension tables and what is a fact table is all about? So here in the case of star schema, I explained what exactly the dimension tables are. Okay, so in the interview, they will ask you, can you please tell me the table names that you have used it in your project? Okay, and if you are in a retail, it is very simple. You can start with product, category, dimension table. Date dimension is, there is a separate table for date. When it comes to analytics project, they maintain a separate table to hold the date related data in it. Okay, it will have the date and month, quarter, year, month name, and day name. Everything will be there. Okay, all the date related data, they store it in a separate dimension called date dimension table. And then something like the territory, all these tables, right? You need to remember. So on top, so these are the common things which you comes to into your mind. So you don't have to memorize. So when it comes to retail domain, right? So what comes to your mind? If somebody is asking what are the tables involved, so obviously customer should be there, right? Customer, they are the one buying the products. Customer, they buy products. The products, they buy it across the locations, territory, okay, different regions. People are there. They buy it across the thing, and then the specific which date they buy what. So for that, you need to have the date dimension, and then you have something called reseller. So reseller is in this case, right? It is yeah, reseller is another dimension table here. So in this case, which reseller, they sold more products. Take for example Amazon and the Flipkart. So they have sellers selling the products, from their website, right? So they provide a platform for the sellers to, even you can go and sell the products in Amazon. Okay, so they are reseller. Okay, and so which reseller, they are selling more, right? So and again the sales order table, right? So this is a sales fact table. Again, they have kept one more table here, sales order table. Here they just maintain the sales order line key. This line key will get connected with this one. So all these dimension tables, and along with that employees. Okay, but there are cases, right? The employees, they are the one, the salespeople. They are the ones selling your products. Even where you have a store in Chennai or Bangalore, right? So customers will walk into a store. The salespersons, what they do is they go and propose them to buy a specific brand. For example, somebody wants to buy a milk. They go and propose them, sir, why don't you buy Arogya milk? Instead of buying the Arvind milk, why don't you buy this one? Right? They influence the customers because they have some kind of additional commissions or additional bonus they will get it. If they propose the customer, they sell it more. So employees is separate table. Employee is separate table. And then price. there is a separate table for price dimension. Okay, usually what we do is the price related information we store in product dimension itself. The cost, price, everything, it will be there. Okay, so or you can say something like employee table. Okay, and and then the region is territory. You can tell them the region, the regions and category table, channels, brand. Per brand, we have separate dimension. All these things, you need to tell it in a pretty fast manner so that they will have a confident on. You should be very confident when you talk to the customer. Okay. And so in that case, right, they will be able to understand, okay, this person is, this candidate is really worked on the real-time projects. Okay, the next one is they will jump into the technical part. Okay, they'll ask you what is DAX, what function that used it, everything. Okay, fine. So the star schema we discussed here, the dimensions. What are the dimensions? Dimension tables consists of what information? All of you, please type it in the chat window quickly. I cannot call each and every person in the interest of time. Okay, this is a dimension table, like customer dimension, product dimension, all the dimensions. What are the informations, the key information that is stored in dimension? Why dimension tables are required, first of all? Why dimension tables are required? Tejaswini, Bhavya, Shraddha. So why dimension tables are required? So why we need to have a fact table? Why we need to have a, this one, the dimension tables? We know what is star schema. The star schema is surrounded by, so in the case of star schema, the fact table is surrounded by dimension tables. So this is, for example, I put one fact table here, sales fact table. That doesn't mean the real world scenario will have only one fact table. Remember that you will have more than one fact table also will be there. Let's say you have another fact table called purchase fact. Okay, sometimes what will happen is you buy products from someone else and then right, you know what, DMart. So DMart, they have their own internal branded, the products like the pulses and all the things, right? They buy it from customers, most likely from the farmers, and then they clean it and then do all the things, right? And then they put it in a pack and then they put their brand name. Okay, so that they'll buy it from separate the farmers or some other people, vendors, right? So that is the purchase fact, something like that. So why dimension tables are required? Star schema consists of fact tables, one or more fact table. Usually, you will have the maximum 2 fact tables you will be having it. The fact table is surrounded by dimension table. Okay, it's not for easy understanding. Okay, so we keep the different multiple dimension tables to do the slicing and dicing. Okay, slicing and dicing. What is slicing and dicing? They may ask you this question. They'll ask each and every question. They will grill you in the interview if you put 3.5+ years. Okay, you cannot say that I'm a fresher. Okay, that is not possible. Freshers, the opportunities are less. The dimension, yeah, we will start with the one by one. The dimension tables. One second. Okay, in the star schema is a simplified dimensional modeling approach. The fact table is surrounded by denormalized dimension tables. What do you mean by denormalized dimension tables? How many of you remember that? I explained you what is denormalization. In fact, we have uploaded the video today early morning itself. I hope all of you have seen it. So what do you mean by denormalized table? No, that is now what you are talking is normalized one, Vinith. Now breaking the into smaller parts or for better understanding, slicing. Okay. So slicing is nothing but yeah, you are correct. Slicing is breaking the information into smaller parts for better understanding. Okay. Slicing and dicing. Slicing and dicing is nothing but if I wanted to do the analysis in any dimension, I should be able to do it. For example, if somebody is asking, can you give me the sales breakdown by product or give me the sales breakdown by the sales territory dimension? Can you give me the sales breakdown by the customer dimension? So then if you have more table, more dimension tables, we can do multi-dimension analysis. That is what your slicing and dicing is all about, right? Slicing, you take any specific data. For example, within this specific region, right? You want the Asia Pacific. What is the total sales we made? What is the total revenue we made in Asia? APAC, APAC. How much sales we made? Okay, so here you are slicing the data. You are narrowing down your analysis towards the APAC region. Within that region, how much sales we made, how many quantity we made, what is the net margin, all the things you are going to do it, right? And again, within that specific region, and how much revenue we made, under each category. The category is another dimension, right? And how much, within a specific region or territory, which resellers contribution was more, and which product they were selling more, right? So you are, for your narrowing down your search to a specific person or specific vendor, specific territory. Within that is your slicing. Within that you are doing, multiple analysis, right? Multi-dimensional analysis. That is called dicing, slicing and dicing. Okay, for example, in the north region, I want to see the north region. In the north region, this is you are slicing the data. You have multiple regions, but you want to do the slicing is on the specific region, slicing. Within that, in the north region, sales breakdown by category. This is one dimension. Category is a dimension table. Here it is not there. I will just put here. You have another table called category. Okay, and then a region. Region is nothing but territory. Okay, region. Okay, something like that. Okay, category, region, and you have something like segment. Segment is another table, dimension table. In which category, in which region, which segment, the sale is more, right? You want to do the analysis. For that, you wanted to access these three dimension tables for this specific north region. So north region is a specific region. You have sliced the data, subset of the data. Within that subset of the data, you are doing further analysis, right? You are doing kind of a dicing, multi-dimensional analysis. You are doing it. Okay, category-wise breakdown of the sales, region-wise, category-wise, segment-wise, sales breakdown in the north region. You're doing so. This is called slicing and dicing. So the dimension table is nothing but it consists of what informations? It consists of the primary key, which is nothing but the surrogate key. Okay, plus the descriptive information, descriptive information about the facts. Primary key, it is also called as a surrogate key. And in addition to primary key, you will have the descriptive information about the facts that you store it in all the dimension tables. Okay, what is a fact table? Here the sales fact table. What is a fact table? What information it has in it? I just told you only two information. So what what is fact table? What does it contains? What does it contains? The fact table. What does this fact table consist in it? Fact table consists of the dimension keys, dimension table keys, which is nothing but the primary keys of all the dimension tables, dimensional keys. Okay, dimensional keys plus facts, or it is also called the measures. Facts or measures, dimensional keys. So here the customer key is there. That same key should be available here also. Only then you can create the relationship between these two tables. When product key is available, the same product key should be available here. Each table, the dimension table, have a primary key, right? That primary key should be available. All the dimension tables, primary key or the surrogate key should be available as part of your fact table. Only then you can do the slicing and dicing. Okay. And reseller key, here you have the reseller key, it is available here. And sales territory key is there, territory key is there. Sales order line key is there, sales order line key. All the dimension tables keys are, that should be available here. In addition to that, the facts and measures, we store it. Facts or measures, okay? The facts, what do you mean by facts? Facts are nothing but the numeric values, quantity, sales, right? And then net margin. These are the numeric values. Okay, facts, it is also called as the facts. These numeric values are called facts. It is also called as the measures. Very simple. The dimension table consists of the surrogate key plus the descriptive information about the facts. And the fact table consists of the dimensional keys of all the dimension tables plus the facts or the measures. What is a fact? What is a measure? Both of them are same, which is nothing but the quantitative variables. Either the quantity, sales, the net margin, and so on. Okay. So these are the things. Very simple one. Okay. And what else? And then they will ask you what is the granularity of the fact tables. Can you tell me the granularity of your fact table? So what is the granularity? So in the same, so what they are asking here is, which means the granularity of the fact table, which means how in depth you store the data here. The daily data we store it here. So either you can store only monthly data, you aggregate the data and store only the monthly data. But here we store the daily data so that if I wanted to see a specific region, total sales, I can see that in my report. But in addition to that, what made up the sales for that? I want to see the item level transactions for each and everything, right? So if you store the data in the day level, so you need to tell them the ground of the fact table. In our case, we store the data at the day level. So that if you tell some number in North region, the sales was, 503,250, and or the quantity sold was, 2,892 units we sold. Okay. So if they ask you, they want to see, each and every transaction, right? Some customer they would have purchased two, some customer they ordered 12, some customer they ordered 3, some customer ordered 5. If you finally add everything, you get this one. But in your report, it shows only the aggregated data. If they want to see the detailed data, it should be available, right? So, and only when you store the data at the day level, you should be able to, give the item level or the transaction level data you can display it. Hence, you need to tell them the granularity of our fact table consists of a day level data in it. Hence, we can do the drill down at the day level itself. See, if somebody wants to see the report, your report, listen, year wise, what is the total says, and then quarter and a month. This is the hierarchy, right? And this is the year, quarter, month hierarchy. What is year wise sales? That is what it shows. For example, product A, 2023. We sold 100 units, less than 1,000 units. And product B, 2023, 1,800 products we sold. And if I want to see, I want to see the quarter wise how much sales we want to see. Product B in 2023 quarter wise. So in that case, right, you should be able to drill down to the next level. And again, if somebody asks, no, quarter is fine, show me month level or day level I want to see. You should be able to drill down from year to quarter, quarter to month, month to day. That I will show it to you when I start do the data visualization training. Okay, that time we'll be able to understand what is drill down, drill up, and all. Only when you store the data at the day level, you can navigate from year to quarter and quarter to months and months to day, right? So for that reason, we store the fine granular data in our fact table. So you tell them the granular of our fact table, sales fact table, consists of the day level data in it. If you are into banking domain, so what are the dimension tables that you are using it? They'll ask you because you are a banking staff. You have been working in the bank for the longer time. You know the domain very well, the business very well. But they will ask you what are the tables that use it. So you can tell them the dimension tables like account types. So the account type consists of the account type ID, account type name, what are the types of accounts? Savings, checking, credit card, loan. These are the different types of accounts, right? You can tell whatever, and then interest rate, minimum balance. You need to tell the column name also. But one or two tables, if somebody is asking you how many dimension tables you are using it, so if you tell them, we are using almost 10 to 11 dimension tables, can you tell me the dimension tables? Customer dimension, product dimension, region dimension, and the employee dimension, and the brand dimension. And then we are using the purchase fact table, sales fact table, and reseller dimension table. And these are the dimension table. If you give the list quickly, they will understand, okay, this guy really worked on the real-time project. Okay. And then they'll ask you, can you tell me what are the facts that you used it? That means in the sales fact table, they are expecting what facts, the numeric values, okay, that you need to tell them, so that they will gain more confidence. And in the case of bank, what kind of fact tables you can tell? In the case of banking, you can tell the fact tables like the loan fact, right? Loan fact you can tell. Every month, the loan transactions will be stored, right? And apart from this, you have transaction table. The transaction table on a daily basis, which customer is, how much money is deposited, what time, what day, how much money they've withdrawn, all the details, the transaction fact table will be having in it, okay? So that is how they'll ask you the questions. Please remember this. Attending the sessions are not important. You don't even have to watch my videos if you store it directly in your brain, okay? Your loan application fact, credit card transaction fact, account balances fact. Note it down everything, okay? A loan payments fact table, investment transaction fact table, fraud deduction fact table. You can tell, this many number of fact tables we use it. And when it comes to dimension tables, we have something like account types, loan types, credit card types, transaction type, channels, which channel we sell, online banking, mobile banking, ATM, branch, and channel description. These are the informations we stored in channel dimension, promotions dimension. So promotion ID, promotion name, description, start date, end date. In each promotion have its own start and end date. The region name, customer segments, products. When it comes to banks, the products are nothing but the savings account, credit card, investment account, and so on, right? So if you tell like this, they will gain confidence. Then they will jump to the next question. They don't want to waste time because the interview time is just 1 hour. They want to assess in other aspect also. Okay. First question was the screening question to understand whether you really worked on the real-time project or not. So, okay, now you understood what is dimension tables and what is fact table. If you have as many dimensions as possible, you can do that much in-depth analysis. Okay. So star schema is nothing but the fact table or the fact table surrounded by multiple dimension tables. Okay. So like I said, right, keep all values in fact table, numeric values in your fact table. Look here, we have promotion dimension table, customer dimension table, and then date dimension, currency dimension table, sales territory dimension table, product dimension table. This is my internet sales fact table. In this case, all the dimension table keys will be available here. Along with that, you have the order quantity. This is your one of the fact, the order quantity, and then sales amount, extended amount, discount amount. All these are called your facts or measures. Okay. The dimension table contains of the descriptive information and the surrogate key. Okay. So what do you mean by descriptive information? Like I said, you have the sales amount, right? For quarter one, you have the date dimension table. With the date dimension table, you are filtering the sales table. You want to see last 3 quarters sales performance, sales amount. Q1, you have 100K, and Q2, 150K. Q3, you have 200K. Okay. Q1, Q2, Q3, you have 200K. So if I say in Q1, 200K, if you say simply 200K, fine. If they ask you, so 200K we made in which territory? right? To answer the business questions like this, if you have the dimension tables already available as part of a data model, you should be able to answer the questions, right? That's the reason why before we start do the report development, everything, or the ETL part, the data loading part, we design all the required tables and all the columns that are required. We just define everything. And then what we do is we will store the data. Once we store the data, we'll be consuming the data. So when we store the data, we store the dimension tables will consist of the surrogate key, which is nothing but the primary key, and then descriptive information. So in this case, that if you see only the territory key will be there. Territory key will be there. But what is the name of the territory key? That name will be available here. Okay, because you cannot keep the name of the territory and the territory group, territory country, everything here. If you keep everything here, let's say you have 100 million records, 100 million duplicates of this value will be there. For example, in a single invoice, you purchase 4 products, or let's say in a single invoice, let's say you walk into the store, right? Let's say Reliance store, you are walking there, Smart Point, you go and buy 15 items, you buy it in a shop, including vegetable, grocery, everything, and they do the billing. And for 15 items you purchase, along with that, if the display, this customer is from north region, 15 times with the north displays, it's a redundant information. For that reason only, the one-time information they store it in the dimension table, the detailed information they store it only in the fact table. But if I wanted to give some context to the facts or measures like sales amount, order quantity. So if I say order quantity is 100, the next question obviously which comes into mind is, hey, which product, man, which product, we sold this many quantity. Is this all the quantity put together, all the transaction put together, what is the total quantity? Or any specific region or specific product, we sold this many quantity, right? So if I say, yes, this is for so-and-so region, okay, give me the region key or territory key. So territory name, only territory key is there. You need to join the territory key with this table's territory key and do a lookup for this corresponding territory. Say the territory key is 100 here. You do a lookup here, 100 is available here. What is the corresponding name for the territory? Okay, APAC region, territory. Okay. Oh, that APAC you'll be displaying it along with the quantity and sales amount, so that, oh, in APAC region, Asia Pacific region, we sold this many number of quantity, this much sales we made in Q1, Q2, Q3, and so on. So without the dimension tables, the descriptive information, how can you give the context to these facts? So that is the reason why you need to have the dimension tables separately. You might be asking this question, so why can't I keep all the things in a single table? It is going to be mess, and it is going to cause hell lot of storage space. It leads to store huge volume of data. You end up storing petabytes and above volume of. Already you are having petabytes and above volume of data. You are going to have the redundant information on top, stored in your table. For that reason, what we do is logically we come up with separate entities for each the actors. For example, territory is a separate table, promotion is a separate table, customer is a separate table, and employee is a separate table, product is a separate table, category is a separate dimension, brand is a separate dimension table, promotion is another table, dimension tables. It's something like, you have a container in your house, in your kitchen, you put all the rice in it. You put all the rice, oil, everything you mix up and put it in a single box itself, no, right? You keep oil separately and you keep the masala items separately, and then you keep the rice separately, isn't it? So whenever you need it, whenever you want to consume it, you pick up all the items from the relevant containers. Similarly, the data gets stored logically in a different tables. So in this case, the dimension tables will have the surrogate key along with the what information? Surrogate key, along with that, the descriptive information with the facts that will be stored here. Fact table consists of the dimension key only from all the dimension tables, plus it will have the facts in it. Next one is the snowflake schema. So what do you mean by snowflake schema? Snowflake schema is nothing but, okay, and so this one also falls under dimensional data model. It is an extension of your star schema. What is star schema? Your fact tables are surrounded by multiple dimension tables, right? That is what your star schema. And what is a snowflake schema? It is an extension of star schema. It is also like a star schema, but in addition to that, right, the tables are normalized here. So we here the dimension tables in the case of star schema are denormalized. Denormalized. The dimension tables are denormalized. What do you mean by denormalized? Yesterday I told you. For example, yeah, here the customer dimension table. Yeah. So what do you mean by denormalized? Exactly, Shayas. Okay. Combining multiple tables into a single table. For example, you have the customer table available in your source system. Okay, so this is what your OLTP system, you have your e-commerce data stored here, right? You have the customer table and then address they keep in a separate, table. This is for OLTP purpose. They do the normalization. Please note down everything, normalization. The tables are normalized. That means they don't store all the information in a single table. Here also they store it. They decompose the table and store the relevant data into more than one table. Okay, one or more, more than one table they store it. So what we do is when it comes to the data warehousing, to improve the report performance, we denormalize the tables. Denormalize the dimension tables. Don't tell fact tables. Okay, denormalize the dimension tables. That means we combine these two tables data into single table. Why you need to have a separate table for customer? Why you need to have a address separate table, right? It's something like, yes, you have to keep rice in a separate container and you need to keep oil in a separate container and you need to keep the masala items in a separate container. But what it is, you buy some container wherein you have small box, right? You put pepper powder here and you put curcumin or something like that, right? You put different things in a single thing, right? Something like. So what we do is instead of having two tables, we are going to store these two tables data are relevant. Customer address, we join it together and we keep it in a customer dimension table. This is called denormalization, guys. In the OLTP system, the data or the tables are normalized. Why? Because the table should have less volume of data. Okay, and because multiple people are accessing the source system databases concurrently, simultaneously, hence the table should be normalized in the OLTP system. When it comes to data warehouse, the tables must be denormalized. Try to do here also we keep separate tables, but we try to reduce having multiple tables. Any related information, you can combine it together, put it in a single table. Here the customer and address, these two are, we combine it and then we store it in a single customer dimension. This is called denormalization. Why we need to do the denormalization? Because in the data warehouse, each table consists of millions and millions of records in it. If you join multiple tables, right, the joining is a very expensive operation. When you join multiple tables, it will literally slow down your report performance. For that purpose, we store the relevant information. We'll try to store the relevant information as much as possible in a single table itself. This is called denormalization. But when it comes to Snowflake schema, it is also similar to your star schema, but here we are breaking down a single dimension table into more than one dimension table. Contrary to the star schema, we combine more than one table into a single table. Here, we are splitting a single dimension table into more than one dimension table to store the information logically into different tables. Okay, here you have the dealer, location, and country, right? Here you can combine all the data into a single dimension or dealer dimension. The dealer dimension, so we can keep location and country name. But here what they did, they wanted to optimize the query performance and also they wanted to reduce the redundancy. Okay, reduce the redundancy in the data so that it doesn't require too much of storage space. Okay, so what they did, they broken down a single dimension table into single dealer dimension table into three separate dimension tables. Okay, I think somebody else is accessing my laptop. Okay, the dealer dimension table. Okay, so they splitted the dealer dimension tables in 3 different tables. They will ask you what is Snowflake schema. Okay, and the Snowflake schema, well, in order to address the redundant information, redundant, redundant. In order to address the redundant data, they decompose. Decompose means splitted the table. Decomposed as a dimension table into 3 different dimension tables. So they'll ask you what tables can you tell me? You can tell dealer dimension table. So what we did, the dealer dimension itself, instead of storing the location country together, we splitted them and stored the location separate in another dimension table, country in a separate dimension table, dealer alone in my. All these tables are linked by ID, the key columns, location ID and location ID got linked, country ID and the country ID got linked. So that what will happen is if you wanted to find out the revenue by specific dealer, country-wise, dealer-wise revenue performance, right? So you need to join these 2 tables, and then this table will get joined with this one. Here, this table has to join with this table has to join with this table, right? Rather, if you have all these 3 tables put together, available on, all these 3 tables data put together available in a single dimension table, you don't need to join multiple tables, right? But here in the Snowflake schema, to address the redundant data issues, they splitted that. See, they will ask you, see, if you learn any topic, guys, in the world, first ask these 3 W's. What is Snowflake schema? Why data Snowflake schema? And again, when it comes to again, when you start explaining this Snowflake schema, we decompose a single dimension table, 3 dimension tables. That is we did a normalization. This is called normalization. So why did you do the normalization here? In star schema, you did the denormalization, whereas here you are doing the normalization. Why do you need to do the normalization? Because we want to address the redundant data. If I store everything in a single table, it consists of humongous amount of data. Hence, we splitted the single table into more than one table logically, the relevant tables. But here, the flip side of this one is you need to join multiple tables. But what Microsoft themselves, they recommend is use star schema. Don't use wherever it is required, right? You try to use only star schema. That is the best practice recommended by Microsoft. Okay. You can cut short the discussion by saying this way. Okay. But if they ask you what they interview, they'll ask you this one also to understand how in-depth knowledge you have it. Snowflake schema is an extension of star schema. It is also like fact tables are surrounded by dimension tables, whereas here the dimension table, in some cases, right, some dimension tables, not all the dimensions, some dimension tables, we have normalized it. Normalized in the sense we decomposed a single dimension, multiple dimension tables. For example, we have dealer, location, country. We are, we splitted the dealer dimension into, like this. They'll ask you what is the table name and why you splitted. Can you tell me those splitted tables, everything? So here the data will be, here we have created the dimensions in a hierarchical way, right? So this is the country is the hierarchy, and each country you have different locations, right? Location 1 and like is location N. Okay. In each location you have multiple dealers, dealer 1 up to dealer N, dealer 1 to dealer N, right? So this is location 1, location 2. So hierarchical, way if you want to display the data. So for that reason also, not only to address the redundant data, even to display the data in a hierarchical way, we have used this one. Okay, without this also that is possible. Even in star schema also you can create hierarchy as part of the data visualization. That I will show you to later. But if they ask you the main benefit of this one, right? Why did you do the Snowflake schema? Because the customer, they themselves designed the data model. We are mandated to use their model. They created like this. They are supposed to use their model, that's all. Though we proposed to them, why don't you use star schema? They told, no, you are supposed to use star schema. See, clearing the interview also, right? You need to have, not only if you have the technical knowledge is sufficient, But again, you need to use some strategy to convince the customers. You can tell them here, this is the one they gave us the Snowflake schema. The reason is they wanted to address reduce the redundant storage. They want to reduce the storage space. Hence, they created. Apart from this, they wanted to the perform some kind of hierarchical analysis. For that reason, we have used. And when you say hierarchical analysis, also they wanted us to normalize the dimension table. The next question which they will ask you is, fine. In that case, you can create hierarchy as part of your data visualization itself, right? Why do you need to create hierarchy at the table level? That feature is available as part of the data visualization itself. Why do you need to do it here? So in that case, you can tell them, no, this is the model. They mandated us to use that. Okay. So this one easier to implement. So now you understood what is Snowflake schema. It is an extension of star schema. So here in the star schema, what we did, we have normalized the existing dimension table, not all the dimensions, some dimension tables. For example, you need to code this example, table naming tell, and how, what are the other tables, how you split the table, what are the names, you can tell them. That's all. Okay. So due to multiple tables, query performance is reduced. Since you have splitted a single dimension, multiple dimension table, it will slow down your report performance. Okay, but the advantage is here is it will require less storage space compared to your traditional, or compared to your star schema. Because in the star schema, you combine all the three tables. You denormalize these three tables and put it in a single table. The opposite is your Snowflake schema, right? But not all the dimension tables you will be doing the normalization. So here logically, right, I want to see, like I mentioned, country under country, each multiple location, each location multiple dealers. Hierarchy, well, if you want to create the hierarchy of the reports or something, in that case, so it adds additional dimension, usually representing hierarchies, and reduce the storage space. But the disadvantage is query performance will be slow. End of the day, the performance should be very good, right? If you want to see a specific report, it should be available reasonably in a matter of 10 or 15 minutes. But if it takes 4 hours, what will happen? So now you understood what is star schema, Snowflake schema, what are dimension tables are all about, and what do you mean by fact tables. And also I have told you in the banking domain, what are the tables that you can tell it to the customer at the time of interview. And retail also we discussed about the tables. See, retail, it is common, right? You take any retail or grocery store, anything. These are the tables are mandatory. Apart from this, you have the store dimension table, the retail. Okay, whatever I have explained, right? Along with that, you need to tell them store dimension, region dimension, date dimension, the product dimension, category dimension, brand dimension, promotion dimension, price dimension. Also, some cases they keep it separately. If you give the longer list, they keep quiet. Oh, this person. Okay, now screening is passed. This guy really worked. Okay, and the next one is how strong he is with respect to the concepts, the functions, all the things they'll ask. So what is fact table? We already discussed. These are the facts, right? Unit cost, sales, revenue, profit, unit sold, everything. So here, the data in fact table should be sliced and diced by the data of dimensions. With the help of the dimensions, we'll be able to slicing and dicing the fact table. The fact table has a many-to-one relationship to every dimension. Okay, measures are usually sliceable. Okay, and this is what fact table is. So there are different types of fact tables available. Transactional fact table, I told you, right? In the case of transaction, every transaction made by the customers in the case of bank, that will be captured in a table. Periodic snapshot. There are some fact table. It doesn't involve capturing the data in real time. Every once in a week, they are going to update the data there. Okay, accumulating snapshot is another type of fact table. So here you do some kind of aggregation and then you store the data. Okay, instead of storing the daily data, weekly, what is the week one total units sold? That kind of thing. You'll store it here. Next one is the factless fact table. The interview, they'll ask you this question, guys. Factless fact table. What do you mean by factless? It's a bridge table. So what does it say? Factless fact table. I told you fact table. What is fact table? Fact table consists of all the dimension tables, dimension keys, it will have it, plus the facts in it. Here the fact plus fact, that means fact table will be there, the fact will not be there. That means only the dimension keys will be there. It acts as a bridge table. This we will see it little later. So remember this. So all these things we discussed in yesterday's session, one to one to many, and many to one, and one to one relationship. All the things we discussed. And also we have seen how to create a relationship between the tables in the Power BI desktop model. We have seen it, and the dimension tables are also called as a lookup table, and the fact tables are also some cases they call as a data tables. Remember that, okay? So fact table carries all the transactions, lookup table or the dimension table carries all the filtering information. So next, we will see what is this one.